Hey guys, and welcome to a brand new tutorial. This tutorial is for QuickGame version 0.2, which released about 8 hours ago, and it also included Lua interpreter support. So right here I've downloaded the Lua interpreter. You can get the latest release of QuickGame down in the description. It includes the interpreter, which is this interpreter.zip. I've extracted it and put out the eboot over there. And the source code will also be on the description as well for QG Pong PSP. If we go ahead and start, we'll need a script.lua file. So we'll do script.lua. And overall, it's pretty simple to use this Lua API. So we're going to do while QuickGame.running do end, and this will be our main loop. We'll do input.update, and then we'll do graphics.start frame, and graphics.clear. We'll also do draw, and then graphics end frame. And then we'll have update as another method here. Update will take in delta time, so to make a timer, we do timer equals timer.create. And then we run timer colon delta. Colon is basically using the meta table to use the meta method, in this case the delta time. And then we'll create a function for update, which takes in dt. And we'll do a function draw, which takes in nothing. At the beginning here, let's define a couple colors. We'll do first off the clear color, which is just going to be this sort of gray color, so 32, 32, 32, 255. So this is RGBA from 0 to 255. Green. So this will be the color when the green team wins, or the green side wins, I guess. And then we'll have the purple, which is the other side. So the color for when the purple wins, which is going to be purple. And then for now, we'll do graphics.set, clear color, and that will be set to our clear color. Some other useful colors we can have here is going to be white. So this will be for the center line, I guess, or the center dotted line, whatever you call it. We'll have actual green, so color.create. We'll do 0, 128, 0, 255. Then we'll do purple, which is the opposite. And then we'll have yellow, color.create, 255, 255, 0, and 255. So it's a bright yellow. Oh, whoops, end frame still takes the boolean. It is true. There we go. And so far we have this blank gray screen. We have a bunch of colors defined, and we've set up our current color. The next thing we're going to do is then we're going to establish a lives system. So there will be a certain number of lives on the green team and a number of lives on the blue team, or the purple team, sorry. And then this will be, for our example, we'll just do 5 here. So we'll do R lives and L lives. So this is left side lives and right side lives. And they're both going to be equal to 5 to begin with. We can then go ahead and draw. So for I equals 1, L lives, and then 1. So what this syntax is we start at 1, we go until the number of lives, and we increment each phase by 1. So then we'll do primitive, draw, triangle. So we're going to put it at the left side, so about 48, and then each one will be spaced out by 32 units. So spacing is just multiplying by the I value, and then 266. This will be our position. It will be on the top of the screen and will be down by 6 pixels. So then we'll have a size of 12. And the color will be green. Then we'll do the same thing, but for the right side, our lives. And then this will be 480 minus 48 is the first value. And that will be minus 32 times I. And these will be purple. We'll also do the center line here. So to draw the center line, we'll do 4 I equals 0, 17, 1. So we'll draw 17 times. Do primitive dot draw a rectangle. So this will draw a rectangle. And we'll center it in the middle of the screen, so 240. And then 0 plus I. So this will be a dotted line, essentially. And it will be I times 16. And then our actual size here will be 8 by 8. And it will be white, and there will be no rotation. So this will be all of the static objects on the screen. And as you can see, this is the number of lives on the left, number of lives on the right, and then you have the dotted line in the center. So then the next part will be actually creating and managing the paddles. So the paddles will have the paddle left, and this will be the Y value, and the paddle right will have another Y value. We'll also have the ball. The ball has an X value, 240, and ball has a Y value, 136, which is the center of the screen. To start off, then we'll have the ball velocity is equal to math.random 0 to 1. Then we'll subtract 0.5 times 300 pixels. So that will start the ball traveling. Also do the same thing for Vy, but instead of this, it will be math. And then this will be negative 10, comma 10. Also need to make sure that this is nested properly. And then this will just be times 30, because it can be a much larger value. And to make sure our numbers are truly random, we'll do math.randomSeed, and it has to be OS time. So now we will create transform objects, and these transform objects will be what we use to manage both the position and the collision boxes. So we'll do paddle transform for the left side, just transform.create. And we'll do the same thing for the right side. Then we'll create a ball transform. And then we'll have one for checking the future position of the ball. And that's that. So the top part here is colors, this is data, and then this is our random ball, and then our transforms. Past this, I don't think we need any new variables. This should be enough for the majority of our application. So in our update function, we'll do the ability to move the paddles now. So this will be moving left paddle. So if the input button is held for PSP up, then we'll do paddle L equals paddle L plus delta time times a velocity. In this case, we want them to be able to move the entire screen in 1 second, so 272. And then the other case will be the button held is down, and that's just negative. We'll also make sure that this can't go off the screen, so if paddle L is greater than 240, then paddle L has to be 240. And if paddle L is less than 32, then paddle L equals 32. And this is because I envision having a 64 long paddle, so it's 272 minus half of 64, which is 32. 272 minus 32 is 240, and 0 plus 32 is 32. Then we'll do the exact same thing for the right side. So to just copy that, do move right. The up will be PSP triangle, and the down will be PSP cross. Then it will have to be paddle R for all of these. Perfect. And then we can actually set the transforms here. So we'll do paddle transform L, set position. and that'll be 24 and paddle left, and then transform right. So we moved to 24 units from the left of the screen, so here it has to be 24 from the right. 480 minus 24 is 456, and then transform right, set position. Now that we have the transforms, we can go into our draw method and we can draw the two paddles. So to draw the paddles, we just do primitive.draw rectangle, and then we can actually pass in the transform, and then we can do the color. So we can do it for both of these. So R and then purple. In order to set this up, we'll also need to set the scales for these. So paddle transform L is going to have a scale of 8 by 64. Same thing will happen for the right. Cool, left and right. And then we'll do the same thing for the ball, and the ball will be 8 by 8. And it'll be a circle. But pretty much the hitbox is going to be square anyways. Also note, I made a small typo here. Ball VY has to be negative 10, 10 times 30. I thought I did, but I didn't. And as you can see, we have these two over here. If I hit the keys here, it goes up and down, but cannot go past the edge. The same thing happens on the other side. So you have two players able to move their Pong, I don't know what you call them, pucks or paddles, on each side now. So the next thing will be doing the ball. So for the ball, we're going to do primitive.draw circle, because it's a ball, and then we'll do ball, and it will be colored yellow. That's why we defined yellow earlier. So down here, let's manage the actual ball itself. So we'll have a potential X. Potential X is ball X plus ball Vx times delta time. Same thing happens with Y. Just switch the value to be Y. And then this will be where we set the check position. So the ball check, set position, potential X, potential Y. Ignoring the collision cases for now, we'll set ball X equals ball X plus ball Vx times dt. Same thing with Y. And the Vx slash Vy will end up changing depending on if there was a collision or not. So then here we'll also say ball set position to ball X and to ball Y. Cool, now that we got that, let's do the basic intersection. If ball check intersects the paddle transform on the left, then we'll just do the ball velocity X is equal to 200, and the ball Vy is equal to, so if you've ever played Pong, you notice that whenever you go to like the edges, it does a different, it goes in a different angle. The way to calculate this is actually say ball Vy, and then I'll do subtracting the difference between the positions. So taking the paddle position minus the potential position, and then multiplying that difference by 10. And that's what actually is enough to change like the position of the, or the speed at which the ball is moving on the y-axis. Which is a really cool formula, by the way. Same thing will happen here, transform R, but it will be paddle R, and then the velocity is on the other direction. We'll also have another concern here, what happens when we hit the top of the barrier, or the top of the screen. So if you hit the top of the screen, that'll be if the potential Y is less than 4, or the potential Y is greater than 268, because our ball is 8 by 8, so it's 4 radius, so 4 from the boundaries. So then ball Y is equal to the opposite, ball Vy equals to the opposite ball Vy. There we go. That'll end. The other case now is what happens when we go and pass the number of lives. So if we do that, we'll do if potential x less than negative 100, then that means the left side lost. So L lives equals L lives minus 1. And we'll do something called reset partial, and I will define that method in a second. And the same thing will happen if the potential x goes to greater than 580. So basically, we're just saying 100 units from the left or right side. And then this will be r lives minus 1. So we'll have reset partial, and define reset partial, function reset partial, and then we'll have end. And pretty much what it does is that we're going to have to say ball x equals 240, ball y equals 136, ball vx, so I can just copy this line here. So randomize the ball again, go in a random direction. Now, if you actually wanted to, this is an extension exercise you could do. You could make it so that the ball actually switches what side it is based on what turn it is. So at the beginning it goes to one side, and then every single one it alternates. That's another way to do it. We'll set the paddles to be in the middle because you don't want someone to have an unfair disadvantage here. So paddle left, paddle right. And then we'll set the positions as well. So just use set position right here. So we have the reset partial on both of those. Now, if we go ahead and run the game. Alright, oops. I messed that. Okay. So, if you can see here, basically the ball is properly moving through space. And I'm trying to play the game against myself, which is a little bit hard. But as you see, if someone loses the ball, so whichever side does, you can end up seeing that the number of lives is decreasing on the top, and then the total number, the total thing resets. And as you can tell, based on where I'm hitting it, it changes the way that the speed works. So if you like bounce it on the corners, it usually goes way faster and becomes harder to hit track. Now, there's a problem though, and we'll see it in a second. I just intentionally lose. The game keeps going even though someone clearly has won at this point. And this isn't fair. Also, occasionally you do have this happen where it has like no Y spin at all, so it's dependent on the paddles. It's a good way to test it. So yeah, what happens when we run out of lives? So ideally when we run out of lives, we should know who the winner is, and we shouldn't continue being able to play the game. So what I did here is just do if L lives is less or is greater than 0 and R lives is greater than 0, then we'll actually have the game do the normal functions. Otherwise, otherwise we'll just pull for an input and do a reset. So if L lives is 0, then we'll do graphics set color. This will set the clear color for the background. So if L lives is 0, purple, which is the right side, has 1. Otherwise, this implies the opposite case. So the green has 1, and we end. Then if input.button pressed is PSP start, then we'll do a full reset. So reset full. And the difference between what reset full and reset partial does, here, we'll do function reset full. So it will do everything from the reset partial, but it will also set L lives equals 0 and R lives equal to 0. Or sorry, to 5. Sorry, to 5. There we go. That way, you'll have the full number of lives, and then we'll do the resetting the clear color as well. So set clear color to be clear color. And if we do that, we have our working Pong clone. Very simple, has a very simple way of tracking lives. And it ends up creating, overall, a pretty fun game to play with one person. So with one other person, sorry, that's what I meant. I actually played this at work with some of my coworkers, and my current score is 2-2. So I'm very average at playing Pong. So one extra challenge that you could actually end up doing here is that you could end up disabling like one of the paddles, so disabling the input on the right side, and instead develop some sort of AI or some sort of rules-based system in order to actually have an opponent to play this game against. And that could be a really cool idea. So if you guys want to do that, go ahead and try it out. I'd really appreciate it, and that will really help you understand sort of the basics of this game. Anyways, thank you guys for watching. Please like, comment, and subscribe, and have a great day.